Now, let's go for graph sketching. First, let us recap how many basic functions that we have. So first we have linear functions, and then we have quadratic functions, then we have cubic function, and then we have reciprocal function, we have surd function, and absolute value or modulus function. So combination of more than one this previous function, so it will give you the piecewise function. Okay, now let's sketch the following functions. So let's say we have y is equal to 3x minus 4. This is linear functions actually. So to sketch this graph, so you have to find the intercept first. So to find the intercept, so you just substitute in x is equal to 0, when x is equal to 0 and y is equal to 0. So when x is equal to 0, then I get the y is equal to negative 4. So this is the y-intercept. When y is equal to 0, then I get x is equal to 4 over 3. So this is the x-intercept. Then you just plot into the graph. So you get this. So you get straight line. So this is linear function. So next you want to sketch the graph of a quadratic function. Let's say we have y is equal to x squared minus 4. So first, so you must find the intercepts. So how to find the intercepts? So just substitute in y equal to 0 and x is equal to 0. So when you substitute y equal to 0, then you get x is equal to plus minus 2. So therefore, you have x-intercept is 2, 0 and negative 2, 0. While the y-intercept is 0, negative 4 when you substitute x by 0. Then you just connect all the 3 points there. So you get the quadratic graph is in U shape. This is what we call is parabola shape. Okay, so this, why is it U shape? Because in front of x squared, the coefficient is positive number, that is positive 1. So it's different for this function. So if we have y equal to negative 2x squared plus 5x minus 3. So again, so you see the coefficient of x squared is negative 2. So the graph should be open downwards. Okay, but still you have to find the intercepts and then you plot into the graph. So you can do it yourself. You can have a try on this. So this is the minimum point, but for negative sign of coefficient of x squared, you have to find the maximum point. To find the maximum point, you can use completing the square or whatever way we have learned at previous. So now cubic function. So we have function y equal to x cubed plus 2. So x cubed plus 2, again you have to find the intercepts. So how to find the intercepts? You just substitute in x equal to 0 and another one is y equal to 0. So when you substitute x equal to 0, you get y is equal to 2. When you substitute y equal to 0, then you get x is equal to negative 2. Now we go for cubic function. So if you have y equal to x cubed plus 2, so as before, you have to find the intercept by substituting x equal to 0 and y equal to 0. So when x is equal to 0, so you get y is equal to 2. So when y is equal to 0, you get x is equal to negative 1.26. So from these 2 points, you just plot into the graph, then you get this graph. Okay, so now next function. So you have y equal to x cubed x squared times 2 minus x. Again, so you have to find the x-intercept. Sorry, you have to find all the intercepts by substituting x equal to 0 and y is equal to 0. So you can try to do it on your own. Okay, now, so let's look at this function. So this is reciprocal function. So I'll show you this one. so you have to do it on your own on the other one. So you have fx is equal to 3 over x. So this is special because you have to consider the condition of this function. Okay, so what is the condition of this? So what is the condition? So the condition is x cannot take 0. So you cannot take x is equal to 0. So x cannot take 0. Why? Because if x is equal to 0, then fx is undefined. So because of that, so you can say that x is equal to 0 is actually this is the vertical asymptote. Okay, and then what else? So if y equal to 0, so also x is undefined. If fx is equal to 0, x also is undefined. So when fx or y is equal to 0, then you have x is undefined. So y equal to 0. So y is equal to 0 is another asymptote, what we call as the horizontal asymptote. Okay, so next, because of x equal to 0 and y equal to 0 are the asymptotes, so there will be no intercept. There will be no x-intercept, there will be no y-intercept. So now we sketch the graph. Okay, so x equal to 0, so this is the vertical asymptote. Y equal to 0, this is the horizontal asymptote. So how to sketch the graph then? So you just substitute in the any value. So let's say you take x is equal to 1. So if x is equal to 1, then f1 will be 3. So you get this. Okay, so let's say this is the point, you plot the point. So but when x is equal to 2, so you'll get 3 over 2. 3 over 2 is 1.5. So here. Okay, so if you carry on, if you continue substituting x by any value, then you'll get this graph. So you have this. So as x approach to infinity, then the graph is approach 0. So same to this one. So as x approach to 0, then I'll get fx is approaching infinity. Fx is approach infinity. So same to this one. So if x is equal to -1, 3 times divided by -1 will give you -3. Here is the point. And then when x is equal to -2, so will give you -2 over 3. So this is the point, -2 over 3. So if you continue if you continue find the f of x by substituting any values of x, so you'll get this. So as x approach to -infinity, then the f of x will approach 0. When x is approaching 0, then we'll get f of x will approach -infinity. Okay, so you'll do the same thing for this function fx equal to negative over x minus 1. Okay, so maybe we can discuss a little bit on the condition. So what is the condition of this function? So confirm definitely x minus 1. So this is the denominator. Should be cannot take 0. So meaning that x minus 1 cannot take the value of 0. So meaning that we have x cannot equal to 1. So this x equal to 1 is the vertical asymptote. Is that clear? And then what's next? To find the horizontal asymptote, so So I leave it to you to find the rest of the two setup. So I leave it to you to finish this question. Okay, so now let's look at third function. So we have gx is equal to third x plus 1. So same as a reciprocal function, it has condition. So what is the condition? What is the condition? So the condition is x plus 1 must always greater or equal than 0. So meaning that x must always greater than negative 1. So that is the condition. So how to find the x-intercept? So to find the x-intercept, okay, to find the x-intercept, so you have to substitute y is equal to 0. So meaning that if gx is equal to 0, then you get square root of x plus 1 is equal to 0. So from here you get x is equal to negative 1. But if x is equal to 0, then you will get gx is equal to square root of 1. So which is equal to 1. So therefore from here you get 2 points. So which is negative 1, 0. So negative 1, 0, negative 1, 0. So this is the point. And you have 0, 1, 0, 1. So this is the point. So from this condition, you know that the graph should be on the right hand side of negative 1. So we just connect these 2 points. Okay, so you have this. So you have this. Is that clear? Okay, now, so I leave it to you to sketch the graph of fx equal to negative square root of x minus 1 plus 2. So you use the same method as f. So you must know the condition, you must find the intercept, and then just plot into the graph. Okay, now let's go for absolute value function. So again, so I leave it to you this the I, and I'll show you the h. Okay, so for hx equal to modulus x minus 1. So there is no condition as third function and as a reciprocal function, because it can take any value of x. X has no condition. So but you can find the intercept. Okay, so what are the intercept? So you can substitute when hx is equal to 0. So when hx is equal to 0, so you have modulus x minus 1 is equal to 0. So this is to find the x-intercept. So from here you have modulus x is equal to 1. So meaning that, so you can x can be equal to 1 or x can be equal to negative 1. So from here you have 2 points, so 1 and negative 1. So let's say this is negative 1, this is 1. So these are the two intercept of x. Okay, now to find the y-intercept. So just substitute when x is equal to 0. So when x is equal to 0, then we get hx is equal to negative 1. So 0, negative 1. So let's say this is a negative 1. So and then this is the point. So just because a modulus is in V shape, right? So you just draw a line of these 2 points, and this one another line. So this is the graph. Okay, so for I, you can do it on your own. Okay, now last one. So last one, we have fx is equal to negative x squared for x less than 0. and x plus 5 for x greater than or equal than 0. This is piecewise function. Okay, so for piecewise function, so you have to consider the domain of each function. Sorry. So you have to consider the domain of each function. So how was that? Okay. So for x less than 0, so the function is negative x squared. So for fx is equal to negative x squared. So meaning that when x is equal to 0, so you get fx is also equal to 0. So this is x, so this is the f of x. So you have the point 0, 0. So this is the point. Okay, but because here we don't have the equal sign, so this one should be empty circle. Okay, so then if you substitute x is equal to negative 1, then you get fx is equal to negative 1 squared, which is equal to negative 1. So let's say this is the negative 1, and then the f of x is equal to negative 1. So this is negative 1. Okay, so you know that for quadratic function, the graph is parabolic shape. So you can continue. You can connect these 2 points, but it must be in U shape. Okay, sorry. So you have this. Okay, so let's say this is the point. Okay, so this is fx equal to negative x squared for x less than 0. But for x greater than 0, then this here should be, okay, this one should be empty circle. Should be empty circle. Sorry for the problem. So this is empty circle, and then just empty circle, and then we just continue here. So this is the graph for fx equal to negative x squared for x less than 0. And then for another one, x plus 5. So when x is equal to 0, so you have fx is equal to x plus 5. So when x is equal to 0, so meaning the f0 is equal to 0 plus 5, which is equal to 5. 0, and then we have 5 here. So this is linear function. So linear function, you just need 2 points. So you can substitute any value of x. So let's say you find f1. So f1 meaning that you have f1 is equal to 6. So let's say this is 1. So you have 6 over here. Okay, so this is 6. Okay, 6. So this is the first point and next one. So you can just connect the 2 points, then we get this one. Is that clear? Okay. Okay. So for K, you can do it on your own. Okay.